Hi everyone, today we are going to discussing about the Model 3, 2 and 3 brief review. On power system, operation and control. First we shall discuss the generator control loops. So there are the two different kind of loops. Generator control, so that is the automatic AVR loop and ALFC loop. So in this AVR loop, we know that some of the blocks, so this is AVR loop. So this AVR loop consists of comparative block, rectifier unit, potential transformer, generator, exciters, amplifiers. So comparator compares the difference of voltage, rectifier rectify the DC to AC voltage, potential transformer it's step up or step down the voltage, generator which is coupled with turbine, exciter is used for generator to excite the generator to the rated speed, amplifier unit which amplify the signals. So here the primary LFC consists of two blocks. One is the speed governor block and hydraulic amplifier block. And secondary LFC which consists of signal amplifiers, integrator block, speed changer block, governor block and hydraulic amplifiers. This all the five blocks which is considered as secondary ALFC loop. And the feedback element which is connected to signal amplifiers, that is error signal for area control error, is frequency sensors. So there are the different speed governing mechanisms. So the speed of the governor will be controlled based on the load. If you increase the load level, there is a change in the speed which is occurs. So that we can call it as governor control mechanism or governor control valve mechanism for the turbine system. So that will be given in the block diagram. So this block diagram consists of speed changers, speed governor, hydraulic amplifier and open and closing of valve. So this speed changers change the speed depending upon the lower and rising of this valve. If it is lower means decreasing level means this there will be a flow of waters inside the block. So this speed changer mechanism will be rising. If you are lower this means it will be decreases. That is closing of valve mechanism. So speed governor which monitor the speed of the system. Speed changer changing the speed. And this is a valve control mechanism depending on flow of waters. If the valve will be open, then the water will be flow to the turbine, then the generator start rotating. If valve will be closed, there is no flow of water in the system, hence there is no generations. This amplifiers depending upon the valve mechanism. So that is open and closing of valve, which perform the function based on the hydraulic amplifiers. There is a mode of governor operations. So this is a block diagram representation of governing mechanism which consists of sensing elements, that is the speed sensing elements, this converter which is used to convert the signals, and amplifier which change or amplify the signal, that is amplify the speed of the signals, and turbine which is coupled with generator. So this is the pictorial diagram or block diagram of speed changes versus load, so which is connected with the control logics. This valve opening and close depending upon the controlling of speed and power generated. So there is a difference in speed which is connected to the summing block and the difference of power which is connected to load controller block. If there is a difference of speed is occurs, then the speed control mechanism control the speed to the desired level and connected to control logic. And there is a difference of power generations, that is a reference power minus generated power. Then its total power variation is depending upon the load control, so which is connected to control logic. So this is the droop characteristics which is shown. This droop characteristics is nothing but speed or frequency with respect to output power. So no load speed, then base frequency or base speed and full load speed. There is the difference of speed which is considered as delta F, and the change in power which is given by delta P. So then the regulating characteristics which is given by R equal to delta F by delta P. So this is the one more droop characteristics which is shown in the figure, and this is the droop characteristics for the two units. F0 is the base frequency, and this is the power output for per unit, and this is the second unit power in PU. So now we shall discuss the problems. Majorly we are focusing on problems. So two identical machines, 1 and 2, have the Drude characteristics 5% and 2% speed regression respectively. They share an initial load of 100 megawatt equally and nominal frequency. If there is increasing of 35 megawatt of load, how would be additional loads will be shared? So first we should draw the graph, that is a graphical representation for both the units. The unit 1 is 5% Drude, unit 2 is 2% Drude characteristics. So if the load is maximum for full load, it is 100% of power, that is system frequency. So if a load is increases by 35 megawatt, that is 135 megawatts. So if you are consider this more than 100% of load, so which is given by the equations. So for the first frequency, it is 49.5 hertz, that is 100% means 0.05 Drude, because here the 5% characteristics means the speed will be decreases by 5% and increases by 2%. So that is 102.5 and 100, and that is P1 is 60 megawatt and P2 is 75 megawatt. So how to get the P1 is 60 megawatt means, here from the graph you can observe that. So P1 P2, if you are adding this, you will get the 135 megawatt. So the total for 100% of frequency load is 100 megawatt. For more than 35 megawatt increases means you can get 135. So for this corresponding frequency we will get the power P1. So that is change in power. So then P2 is also calculated from this. If load is increasing, a power output of machine 1, that is 10 megawatt. So 60 megawatt is power, increases output of machine is 10 megawatt. So 60 minus 50 will get the 10. For machine 2, 75 minus 50, because 100 megawatt load will be shared equally. Then you will get delta P1 by delta P2 equal to R2 by R1. So we will get the value of P2. Now the next problem. Two machines operate in parallel to supply a load of 400 megawatt. The capacity of the machines are 200 megawatt and 500 megawatt. Each has Drude characteristics is 4%. Their governor adjusts the frequencies 100% on full load. Calculate the load supplied by each unit and frequency at this load. The system is 50 Hertz. So there are the two Drude characteristics. So consider both the power of both the units and divided by base value, we will get the per units. So unit 1, 200 divided by 200, 100, we will get 2. Then 500 divided by 100, we will get the 5 PU. So both the machine having the same Drude characteristics, that is the 4%. So for 100% of frequency, the power generated is 100 megawatt. If you increase frequency by 4%, then it is 104%. So divided by base means you will get the 1.04. So for frequencies varies from no load to full load. So we get the value of the frequency. So that is shown in the graph. This point indicate common change in frequency in PU and for different units. Unit 1 which is connected to 2 per unit, and unit 2 it is 5 per unit. So here you have to consider the two cases and find the value of X and change in frequency. So in the first case, change in frequency divided by X, that is the first change of load, that is the Drude characteristics 0.04 divided by power is 2. For second case, change in frequency delta F divided by 4 minus X, that is equal to 0.04 divided by 5. So consider as this is equation 1, this is equation 2. Then you have to find the value of X. So the new frequency is calculated by this equation. Then you will get the equation like this. So you will get to find the value of power supplied by the 2. So similarly, the next problem I have to discuss here. Two generators rated 120 megawatt and 250 megawatt are operating in parallel. The governor settings are in the given a Drude of 4% and 3% respectively. The settings are such that the units operate at 50 Hz on full load output. Determine the load taken by each machine for total load of 200 megawatt The percentage adjustment is no load speed to be made in faster machine is have share load equally. For unit 1, the no load frequency is 4% more than the full load frequency. For unit 2, it is 120 megawatt, that is 1.2 pu. In unit 2, it is 2.5 megawatt. 250 megawatt divided by base means you will get 2.5 pu. You can plot the graph. From the graph, you have to find the value of. This is equation 1. This is equation 2. Okay. So from the point A to B, so this is the intersecting point for both the slopes. This is the crossing point for the first slope and this is the crossing point for second slope. Here we can consider the base frequency as the reference. Draw this reference line and observe the intersecting point, and you can write the equations. AB is nothing but 0.04 minus delta F divided by 0.04, that equal to x divided by 1.2. X is the distance, BB1, then CC1 is 1.2. 1.2 means that is generated power for 120 megawatt of power. And for second unit, that is 0.03 minus delta F divided by 0.03, that is the truth characteristics. That is equal to, in place of x you can write 2 minus x divided by 2.5. If you are solving equation 1 and 2, you will get the value of x and you will get the delta F. So this is the turbine module. So you can find the value of governor module. So that is general representation of governor module, which is shown in the figure. Now we shall discuss the problem on governor module. The single area consists of two generators as follows. G1 is 200 megawatt and R equal to 4% on machine base, and G2 is 400 megawatt and are equal to 5% on machine base. So they are connected in parallel and share a load of 600 megawatt in proportion to their rating of 50 Hz, 200 megawatt of load trip. What is the generation to meet the new load if D equal to 0, and what is the new load? Repeat the same problem if D equal to 1.5. So convert all the values into regulating characteristics. Base is 200. To find the regulating characteristics, regulation into SB base divided by power in megawatt. Regulation is for first unit, it is, you will get base 200 means 200 by 200, it cancel, you will get only 0.04. For second unit, so we will get the base is 0.02. So we know that change in frequency or speed at steady state condition, speed is changing equal to minus delta PL divided by 1 by R1 plus 1 by R2. Delta PL is known. 200 decreasing of power. If load is strip off means decreasing power by 200 megawatt. So we'll get the values. So from this equation, you have to find the value of individual change in power, delta P1 and delta P2. So delta P1 is given by minus delta F divided by R1, and delta P2 is given by minus delta F divided by R2. So once if you are getting the values, convert this per unit to base value. So to convert per unit to base value means multiply the given base values, that is 200 megawatt for unit 1 and 400 megawatt for unit 2. Similarly delta P2, so multiplied with 400. So we'll get the second, sorry, not 400, it is 500. Okay, because 400. Okay, so it is 400 multiplied with 400, we will get this megawatt. So we get the change in power. For the same D value, if D equal to 1.5, calculate the change in speed. So using these formulas, we will get the change in speed and change in load values. Similarly, in the third problem, also you can use the same. So the control area has the following data. Total generating capacity is 2000 megawatt, nominal load is 1500 megawatt, H is given, D is given, that is 1.2%, F equal to 50 Hz and R equal to 2.5 Hz.